Pardon?
For this. I didn't get this part, and I didn't really see what the screen was saying. Is it 2.95 or 2.96?
It's 2.95, but that's okay. I'll get you. Check. Yep. Yep. Take out your, what are we on? This is, I already said it, 7.3 gas stoichiometry. Yeah. Yeah, we did 7.3 gas. No, unless. You gotta go.
And I was like, are you music or you He's like, no, I just don't want to go.
Okay,
I'll make an exception for
so I'm
you.
gonna continue without you, so.
You join. Straight up, you pressured him, and he joined this.
Okay!
It was horrific.
Can I just get your attention up at the front, please? Now, we're talking about our kind of second version of stoichiometry. We did gravimetric stoichiometry. That was all about using masses to determine other masses. Gas stoichiometry is typically involving pressures, volumes, temperatures, things like that. Things that affect gases, right? So gas stoichiometry is typically going to involve either the R constant or the molar volumes. Now, at its core, what is stoichiometry? Like somebody just give me a really concise, short definition of what stoichiometry is. Wim? Yeah, if I give you this much of one thing, you should be able to predict this much of another thing, right? What is the most key number one pivotal step in doing a stoichiometry problem?
Ratio.
Getting the molar ratio from a balanced chemical equation, right? If you don't have a balanced chemical equation, can you perform stoichiometry? No, okay? And so it's really important that we make sure we understand our balancing chemical reactions. Hopefully we finished off yesterday on a little bit of a complicated problem. Was this stoichiometry, did it take up a lot of room in our notes? Yeah, it took up a lot of room, right? And that's because when we do our unit analysis, this is a one-step problem, right? We're just canceling every unit that we don't care about. Really important for us to pay attention. Whenever we write down a unit, I would like you to write down what substance belongs to, what that substance belongs to. We're gonna do one last question all together, and then I'm gonna get you to do some examples for me, and then we'll continue to work on it. Can I just bring your attention to the board, please, just for a second? Just look at the calendar. So we're Chem 20, we're that last column, right? Today we did a lab quiz and we're finishing up gas stoichiometry. Tomorrow we're going to do solution stoichiometry, and that's the last version of stoichiometry. There's three versions. There's gravimetric, right? Masses. There's gases, so using the R value. And then there's solution stoichiometry. And so there's three different types. You're going to have a stoichiometry quiz on Thursday. It's going to be, you get to choose your poison. There's going to be 3 questions on it, and you have to answer 2 of those 3 questions. What do you think those 3 questions are going to be based on? Gas, solution, gravimetric stoichiometry. Okay? So even if you're uncomfortable with solution stoichiometry at the end of tomorrow, you should still be able to do 2 of the 3 questions on our quiz. Is that fair? I just don't want to push the quiz back any more than that because we're going to start qualitative versus quantitative analysis. Okay, example number 1. An individual ate 6 grams of baking soda. I don't know why you would do that. Whatever, seems stupid, but that's fine. And it reacted with the acid in his stomach. His body temperature was 37.4 degrees Celsius. The reaction produces salt water, carbon dioxide, and water. If the maximum volume of his stomach is 2.5 liters and it can withstand a pressure of 49.6 kilopascals, does his stomach burst? Yes. I don't know. My first question to you, is this even a stoichiometry problem? Probably because it's in the booklet, labeled gas stoichiometry. I don't know. What is a stoichiometry problem? Yeah, it should have an equation, right? And it's saying something about one thing and asking you about another thing, right? And so let's see. A man ate 6 grams of baking soda. Sure, no problem. It reacted with the blah, 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 blah. His body temperature is blah, 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 blah. The reaction produces salt water and carbon dioxide. What state of matter is carbon dioxide? It's a gas. When you take a solid and turn it into a gas, is that gas going to be is it going to take up more or less volume than the solid originally did? More volume, typically, right? And so that carbon dioxide, that's what we care about. We want to know if we eat 6 grams of baking soda, how much carbon dioxide are we going to make? So we either have to keep volume constant or pressure constant. I'll walk you through it. This is a complicated problem. We'll walk you through it together. Yes, it's a stoichiometry problem. So we need a balanced chemical reaction. Let's see what 2 things are reacting together. Read the question. What 2 things are reacting together? Baking soda. And we'll talk about what the hell baking soda is in a second. And then what is it reacting with? Acid in the stomach. Okay? So now you don't know this, and that's totally fine. I would give this stuff to you in an exam. I'm just trying to, this is just an interesting example. Baking soda, some people call it nacho. Do you know what I'm talking about?
No.
Sodium hydrogen carbonate. That's baking soda. Sodium bicarbonate. What's the acid in your stomach? Bio 20 people? What? Ugh. Yeah, it's hydrochloric acid.
Is it actually?
Yeah, the acid in your stomach. Yep, the acid in your stomach is hydrochloric acid. So these are the 2 things that we've got reacting with each other. So we've got a reaction. It's sodium hydrogen carbonate reacting with hydrochloric acid. What the hell is the formula for hydrochloric acid? HCl aqueous. And what are we going to make? We're going to make salt water. What the hell is salt water? Salt water plus carbon dioxide plus water. Now this is going to be an absolute nightmare to balance. Or is it? It's already balanced, isn't it? Is it? Double check for me. Thanks, Idris. How many sodiums on the left-hand side? 1. How many sodiums on the right-hand side? 1. How many hydrogens on the left-hand side? 2. Oh, gotcha. Okay, 2 hydrogens. 2 hydrogens. How many oxygens on the left-hand side? 3. And 3. How many chlorines? 1, 1. Boom, done. It's all balanced, okay? Everything is just a 1, 1, 1, 1, 1, 1, 1, 1. So, let's describe what's going on. How much stuff did we add to his stomach?
Thanks.
6 grams of the baking soda. And what do we care about? Do you want to solve for the volume that the carbon dioxide will occupy, or do you want to solve for the pressure that it will create? Nope. Solve for either volume or pressure, not both, because then you have 2 things you're solving for, and that's not possible. Right? They're both equally as easy as each other. Hands up for volume. Hands up for pressure. That's a dead split. We're going to solve for pressure. Yes. Okay, pressure. Perfect. Okay, the reason why we're doing that is because the maximum volume his stomach can hold is 2.5 liters, and also the maximum pressure it can withstand is 49.6 kilopascals. Like this, that's in addition, 49.6 kilopascals in addition to like atmospheric pressure. So what we're gonna do is we're gonna solve for pressure, and we want to see if the pressure goes over this, what happens to his stomach? It bursts. If the pressure is under this, what happens to his stomach? It doesn't. It doesn't burst, right? Okay. So let's say his maximum volume is 2.5 liters, right? And what else do we typically need to know about gases? Pressure, volume, temperature. What do you think the temperature will be of the gas that's created? His body temperature is 37.4 degrees Celsius, right? So let's change that to Kelvin, because if that's the temperature of his body, then that's the temperature the gas will be inside his body. 310.4.
49 kilopascal.
310.4 Kelvin. I was going to say kilos, but Kelvin. Perfect. Okay. Let's think about this for a second. In stoichiometry, you go from moles of one thing to moles of another thing. Can we get moles out of this combination? You need the molar mass. Go right ahead. Be my guest.
To get Kelvin, it's 273 plus Celsius.
One? Oh, yeah, okay. .01 grams and 1 mole of baking soda. Okay, let's think about this for a second. Is it possible, once we get moles of this, okay, so we will eventually get moles of this. Once we get moles of this, can we, using moles, liters, and Kelvin, can we get kilopascals? Is that possible? Yeah. What final additional puzzle piece do we need? R. The R value, and we just don't like. You can put it here if you want, but I'm gonna be lazy and I'm not gonna put it. And then the last thing we need is that molar ratio. Yeah, 1 mole of carbon dioxide for every 1 mole of sodium hydrogen carbonate. So let's go ahead and do this. Let's use our unit analysis and let's solve for this. What do you want? Pressure. Measured in what? Kilopascals. Do you see anything in here that has kilopascals in it? The R value. 8.314 liters kilopascals, I think is the way your magic green sheet says. Nope. Kilopascal liters, kilopascals, doesn't matter. Over 1 mole Kelvin. Now remember, we're going to have different moles here, right? Different moles. So what does this mean? This moles of what substance? The moles of the gas, right? The moles of CO2. So what do you want to cancel out first? Do you want to cancel out liters, Kelvin, or do you want to cancel out moles of carbon dioxide?
Kelvin.
It doesn't matter. So let's cancel out moles of carbon dioxide. Sure, let's cancel out moles of carbon dioxide. Where else do you see moles of carbon dioxide? Molar ratio, that's what I'm talking about. 1 mole of carbon dioxide for every 1 mole of a nacho. Yeah. Moles of carbon dioxide disappear. Gone from the face of the earth. Now what do I got to solve for? Now what do I have to get rid of, I mean? Moles of nacho. How many moles of nacho do we have? Do you know? Do you see anywhere else moles of nacho?
Yes.
Yeah? In our molar mass. 1 mole of sodium hydrogen carbonate is 84.01 grams of sodium hydrogen carbonate. Whew, I can already tell I'm going to run out of room. So moles of nacho. How do I get rid of grams of sodium hydrogen carbonate? 6.0 grams of sodium hydrogen carbonate. Blah. Grams and grams. I'm so close. I mean, we are so close, you guys. We are so close to getting the answer. Let's go back and look at what units are left.
Kelvin.
Kelvin. We got to get rid of Kelvin.
Times 300.
Okay, so where do Kelvins have to go? Top or bottom?
Top.
Okay, top. So Kelvins, 310.4 Kelvin over 1. And then what else do we have to cancel out? We have to cancel out the volume. 2.5 liters on the bottom. Woo! Trust me when I say gas stoichiometry is the worst.
Yes.
Gas stoichiometry is the hardest because when you introduce that R value, there's 3 additional variables that all of a sudden you have to cancel out now. I've got no clue what this answer is. I'm relying wholeheartedly on you.
Wait, doesn't it matter at what rate the carbon dioxide is converted? Because wouldn't you just like burp it out like slow?
No, someone take
My answer to you is stop asking so many questions. How dare you? No, obviously this is a ludicrous example, right? Okay, what'd you get? What pressure?
Someone take
74? 74. 74? 74. 74?
7.4.
74. 7.4? 74. 74 what? Does that exceed the maximum pressure his stomach can handle? Yes. So, because this is over and above, right? This is over and above what you would expect to be able to have in your stomach. So, his stomach, hopefully I spell stomach correctly, his stomach will burst. Because the pressure is too much. Or a fancy smanchy way of saying it is the pressure exceeds the maximum pressure of 49 point something kilopascals. Whatever. Blah, 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 blah. Okay, are we ready
He'll die.
to start trying some problems ourselves? Independently, all on our own. Yes, we are. There's extra practice there, but I don't want you to do those extra practice problems.
It's getting marked.
What?
No, it would just get marked. It would just like.
Yeah, all the notes are online.
It'd be like.
No, if we close all his holes and
Except for the gas stoic stuff. The gas stoic stuff isn't online. 4, 5, 6, 7,
he could just explode and die without having to.
I will answer that question momentarily, but as soon as I stop handing them out, Akula, you have to answer. You have to ask this again, because I will forget. Literally in the next 40
John,
seconds.
should we test that?
5, 6, 7, 8, 9,
I
10.
think we should test that, John.
You're welcome.
Let's test your brother. Yeah.
Yeah, sounds like a
Wow,
good
there's only
idea.
5 of you in this room?
Don't tell him. Don't tell him. Yeah, he's sneaking like 6 grams of baking powder in his next supper.
Okay, good. Yeah.
John, baking powder is different from baking soda, buddy.
Oh, I mean baking soda.
Yeah. I just want you to know.
Wait, you're helping me with murder.
And I'm not helping you.
Yeah.
No.
Here, this is the wrong answer.
I think you're the one of the person. It's your own brother. You accepted the idea.
Okay.
You're a good sister.
So there's 4 questions on here. All the answers are here, right? So for question number 1, the answer is 160 grams of sulfur. That's okay, whatever. I don't care about the answer. What do I care about?
The word process.
The process. Oh, that's such a good word, the process. I care about your ability to actually balance equations, make equations, analyze the stoichiometry, and go through the process of unit analysis. So, what I would like you to do is for the next half an hour, I want you to work on this. It's fine if you get this done, because if you get this done, you can just work on your major assignments or whatever, right? But I want for the first 10 minutes at least, I want you to be totally silent. Don't ask anybody else any questions. This sheet is not due for marks. Are we clear on that? I just want you to try it out all by yourself. If you have questions, of course you can ask me, but you can always go back through your notes as well. We've done enough stoichiometry now that you should hopefully have a good sense of what's going on. I'll for sure help you with balancing reactions and stuff, but the stoichiometry you should do it better. Let me know if you have a question.
Hey, no.
This is emphasizing gas stoichiometry. Every single one of these problems has gas stoichiometry in it. For example, the first question has SDP. So what do you immediately know you should probably use? The molar volumes, right? Molar volumes of gases at STP. You can still use the R value, but that just means you got to look up what STP means on your green sheet. It's whatever you want. Doesn't matter. I'm going to be wandering around. I'm going to be trying to help you out. You gotta go. Yeah, I said you can rewrite it.